session, I will let Ibu Dr. Fitri Hoirunisa to start this session with the introduction about the World Class Professor Program, Scheme B, that he is the principal investigator for this. The time is.
Okay, thank you very much, Bu Galuh, for very kind introduction. So, first of all, I would like to say Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon, everyone. As the how to say organizer of this activity,
thank you, and you.
Very how to say pleased and delight to welcoming you on our program, especially with class professor program. So actually, as Bu Galuh mentioned in the beginning, this seminar, how to say, is organized in line with the world class professor program. So for a brief introduction, please let me some minutes to give you the brief informations about the one of the national program that we earned by chemistry education department. So actually, for your information, this program is not the first time for us, but actually the third one. And consecutively from 2018 to 2020, very fortunate, Department of Chemistry Education of Indonesia University of Education, how to say, receive a very great opportunity from our government to organize the activity that named as the World Class Professor Program. From 2018 to 2019, this how to say programs, they belong to Ristek Dikti, but since 2020, the activity belong to Kemdikbud, yeah, or Ministry of Education. And just for your information, briefly, I would like to introduce. In 2018, we organized the same how to say program. It names World Class Professor Program Scheme A, and it is very huge activity because it involves how to say 3 other university, national university in Indonesia, as mentioned before, ITB, UGM, and also University Melawaman, located in Kalimantan, as our local partner. And the rest is actually the invited professor from abroad, so from Japan, from Sinsu University, from Monash University, from Sunway University, and also from Korea, Yeonam University, and University Malaysia Pahang. At that time, yeah, very fortunate for us. We can have great connections with many prominent professors abroad, and then we try to share their expertise to our society, not only, I guess, in Indonesia, in how to say, in our university, but also for other scientific community in Indonesia. Professor Kanko, Professor Alan, Professor Gil, and also Professor Edward, Professor Yang Gungo, and also Professor Rijalman at that time were joined with us within 1 year. Yeah, the activity arranged within 1 year. And at that time, still we have in the normal condition, we can visit their institution, their research center, and reciprocally, they also visited us here, and we have a very great engagement, not only with our lecturer in department, but as well with the student here. And we very grateful because through this program we can reach several paper on Q1 journal as the main target of this activity, as we listed here. And then secondly, also in the 2019, very fortunate, we also granted by government for the same project with class professor scheme B. We try to make the new connections with different institutions here. So from Japan, we invite Shizuoka University, and as well as the University Malaysia Pahang and University Science Malaysia. And for professor being connected with us for running the same activity at that time. So the main target for this activity is how we can publish the good paper in the very reputable international journal by support and help from the professor that we invite here. So from Shizuoka University, we invited at that time Prof. Awai, and then from Malaysia, we invited Prof. Ang and also Prof. Rijalman, and Prof. Hairu Rijal from ITB, especially we invited as the local professor as well to support our program. And then again, we are very grateful through this program. We can publish again several Q1 journals, yeah, of course with their great support as listed here, yeah. And then this year, again, we are very pleased, we are very happy, yeah, to get again the same prestigious, I guess, grant from the government. But currently, since 2019, the ministry changed. By the end of the 2019, the ministry changed, become Kemdikbud, yeah. That's why the logo also different. And yeah, very luckily for us, we can have the great connections with Professor Pakon, yeah, from Thammasat University, especially he's belong to the School of Biochemical Engineering and Technology from Sirindorn International Institute of Technology. I've been read many information of these institutions and we are very amazed, yeah, with the great projects, with the great achievement, with also the great funding for many, I guess not only national funding provided by Thailand government, but as well maybe from international level. Later on, I do believe Propakon will share with you many great of experiences, how he ran the research project there with his student and also with his collaborator. That would be, I guess, great experiences for us. And then briefly, I would like to introduce who is Propakon. As I mentioned, he's belong, as I mentioned before, to the Thammasat University, and his position is actually as the researcher and lecturer, and in the research institute that I mentioned before, he's actually the head, if I'm not mistaken, for that institute. Yeah, and so far he's very concerned with the development of material science and engineering. Basically, he's very concerned with biopolymer research, biomaterials, as well as nanotechnology. And he has the age index in the Scopus and Google Scholar around 14 to 15. And yeah, very amazing. Still very young, and but citation number is very, how to say, significant. Yeah, hopefully we can follow his great achievement. And the good thing is, I guess that really motivated for us why we invited him for our program. Yeah, because of his great merit. Yeah, he received many great honor and also award from Thailand government as well as from how to say international award that I listed here. And then the other good things from him is, yeah, he really experienced with the many research grant, yeah, not only national research grant but as well international research grant. I read from the CP that provided by research center, his research center, more than 50 something the research grant that he been earned. Yeah, then yeah, I guess it's very how to say, very amazing. Yeah, and also how to say, the other thing that very how to say, inspiring for us, he's also very active in term of not only in term of research but also the publication in many international journal. So quickly, if you want to know into detail, you can put his name on Google Scholar and finally boom, yeah, this is publication will be released. Yeah, and this is some of the list of the journal that I've been checked, which is he has the important role, yeah, as the permanent reviewer. So hopefully someday, if some of you, yeah, scientists from Indonesia would like to apply to some journal that listed here, maybe you will have the opportunity, yeah, which is your paper will be reviewed by him. And then quickly, just we would like to inform you the main activity of our world-class professor program for this year is actually concerned to the two program. One is related to joint publication. As requested by government, we have to target the paper or the draft that we've been prepared to Q2 at least, but hopefully, yeah, Professor Pakon within our 2-week meetings very motivated us, yeah, to try even though to Q1 journal. So I really beg your bless. Hopefully our program can be run well. Yeah. And the second activities for the seminar, due to the COVID, actually we simplified this seminar activities by virtual meeting, and we already schedule for the seminar. So one is the current progress on polymer composite science and technology that are organizing today. And the second one, yeah, we will have the another seminar that will be organized on 30 October 2020. The second one will be concerned with the strategy, yeah, the best practice, how we can publish our research result on the reputable international journal. Yeah, especially for joint publication, we organize the weekly meeting with him through Google Meet or Zoom gitu ya. We have a very fruitful discussion, great suggestion from them, and we can learn a lot ya in terms of refining the paper. And this is the paper draft that we try to target. So basically we have three drafts yeah to be discussed and to be refined with them, and also and as well how to say involving also the colleges from Department of Chemistry Department, as well as the partner from Research Unit for Clean Technology of Indonesian Institute of Science atau LIPI gitu ya, dan hopefully ya all of the draft that we prepare ya can be published through this program. And then just for your information, actually this is the flyer for our seminar. The left side is the one that we are organizing today, and the second one is the future seminar on 30 of October. In detail, maybe by the end of this conference, we will advertise again for the second seminar informations. Bugalu, I guess that's all from my side for introduction. Hopefully it's not consume so much time and we can go quickly to the presentation from invited speaker. Thank you, Bugalu. If you have any question, just put on the chat, chat room. Thank you.
Okay, thank you so much. So I think to optimize the time, we can start the presentation from our two speakers. The first speaker is Professor Pakorn from Temasek University, Thailand. And then the title of his presentation is about functional polymeric materials for sustainable development. Professor Pakorn, can you start share screen?
Okay, thank you.
Yeah, thank you.
Try to
Professor
get
Pakorn,
my
the time is yours.
presentation.
Yeah.
Can my presentation file show up correctly?
Yes, I think it's shown quite well. It's quite clear.
Okay, then I'll start.
Okay.
First of all, thank you very much, Professor Fitri, and also UPI for inviting me to participate in this program, which is I'm very pleased to be to take part in this very good program, and I wish to have a strong collaboration amongst our institute, and this is a very good beginning of the program. And we have many things in common to start our collaboration. If we consider the field of the research, they are also very close among our lab and also the one at UPI. And also, I also have one of my students, a very talented one, that also an alumnus from UPI as well. And this is a very good sign for our strong collaboration. For the presentation today, I will introduce the work that are related to functional polymer materials that are intended for sustainable development, which means they are friendly to the environment, and also we can have this type of material with high value and also very good to both environment and also economic. But before I go to that, I would like to oh, it's still in the note format. I should change this.
So I guess it's already in the good format, Prof, but just you need to slideshow, maybe, the presentation.
Oh, okay. So let me try again.
Okay.
Is this good one? So it show up correctly? Okay.
Yes, Prof. Perfect, Prof. Please.
So before I go to the work, I would like to introduce our university and our research center a little bit. So my university is Thammasat University, which is located in Pathum Thani, right? About half an hour north of Bangkok, if you have been to Bangkok, around this area. So this is our campus. Our university have around 2,000 teaching staff and around 30,000 undergrad students, also almost 7,000 graduate students. For our institute, we are a faculty under Thammasat University that only offer international program in engineering. And unlike other faculty in the university that also teach in Thai language, but we only use English as a medium of instruction in our institute. And we focus very much on research work, and we have like very high quality graduate student, master and PhD student. And if you look at this picture right here, this is Ocean, which is an alumni of UPI University. Yes, and she worked with us on the project related to chitosan, which is one of the very famous biopolymers. And for the presentation today, I will focus on maybe 5 topics here. I'll start to introduce about degradable polymers that are used in a very, very popular term now, biocircular economy. And then within this research framework, we focus on chemical recycling. And the one that we are heavily focused on now is 2 polyesters. And I will give example on 2 polymers, which are PLA, polylactide, and PET. And also give you some example of potential application, which is a high value added product that we can make from these chemical recycling products. On to other separate topic, I will introduce also polymeric micro and nanoparticles and as materials, and also their potential application, which is also our main concern at our institute as well. And finally, I'll talk also a little bit about bio-based chemicals, especially for use as anti-scalants and anti-fouling in water application. So this is the overview of our research center, which is the name is Functional Advanced Material Engineering or FAME. So we conduct research covering the all aspects of materials, starting from material development, synthesis, and characterization, especially for biobase or biopolymer and biomedical materials. Once we synthesize the materials, we also want to use this in application. Therefore, we also work on computational analysis and design in order to apply this to our material that we develop. Once we have the design and the materials, we also develop processing methods or manufacturing method to make the materials, to convert the material into the real products. And we heavily focus on 3D printing technology, and which is one of the rapid prototyping concept. And also we work on electrospinning and encapsulation, which I will talk as the last topic of this presentation. And also on two separate aspects of our research center, we also study the use of plasma and microwave technology to apply this to materials, right? Especially for chemical recycling of the material that I will talk about today. And on a separate one, we also develop like analysis devices for chemical sensor and automation system. So this the overview research focus of our research center. However, for today, I will only take some example of the work to share with everyone today. And I will start with the term circular economy. Right? We know that in the past, we are linear economy, where we take raw materials and then we convert the raw materials into building blocks, into polymers, and into products. After that, we just throw them away. So this is a linear economy that is not so friendly to the environment, and we use raw material not so effective at all. Now, we also therefore circular economy is introduced. So what does it mean, circular economy? It means that so everything that we take from the raw materials until we have the product should be reused in a circular way. We do not throw anything away, or ideally in the future, we should not take any new raw material into the circle anymore. So what does it mean? It means that we will use the raw material that we already use, right? And then after we use them into the products, we just try to reuse them or convert them in some way and effectively, repeatedly use them, right? So this can lead to the sustainable development that I talk about in the topic of my talk we have conducted at this moment. So we focus heavily on plastic or polymers that can be degradable after use. So they will not at the end cause any problem to the environment because they can be degradable after use. So this degradable polymer can be produced from petroleum based, some of them. So we study some of them like PBS, for example, they come from fossil base. At the end, they are degradable. The majority of them come from renewable. We need formation and convert them to polymers. And the one that is very, very important is this one right here, which is try to convert the polymer or the plastic that post-consumer or waste plastic that into polymer, which is a big size molecule.
Professor Pakon, sorry, the voice is not so clear.
Bugalu, I guess we can suggest him to off his video just in case the streaming condition not so good from Thailand side. Yeah.
Professor Pakon, can you hear my voice? Kayaknya keluar sendiri.
Yeah, I guess he has the trouble with the connection. Maybe I will inform him. Maybe we can share the slide from our computer, Bugalu, to make the how to say streaming getting better. Yeah.
Yeah.
Okay. Wait for a moment. We will share his presentation, and then I will try to contact him. Yeah, for continuing the presentation.
Oh, sorry. I think we have a disconnection here.
Okay.
Yeah. Can we do the sharing screen instead, Professor Pakon, so that the connection won't be too much trouble? So if
sure, yes.
Yeah, if possible, we can share screen from our host, and then you can you can use your screen for knowing the flow. And then probably we can also suggest if the connection still not okay, probably you can off your video for your during your presentation. Probably that can help.
Sure.
Yeah. But I think now your voice is quite clear now. So the recipient is better now. So I can hear you clearly now.
So should I continue with my screen then?
Yes, please. It's quite clear.
Then.
Probably you can
right.
video for during your presentation. That probably help. Yeah. Thank you, Professor Pakon. Please continue, Professor Pakon.
Sure. Okay, I'll continue from this page then. So we are working on chemical recycling, and for polyester, that is a quite established technology already. But the main challenge is polyolefin, which is also very, very useful, and we are working on this one heavily at this moment as well. And the last one is also should be the ideal target if we can convert CO2, right, especially from the atmosphere, directly into polymer that are degradable. So these are the scope of our work, and that we work in order to make degradable polymer that can be used as functional material for value-added applications. And now if we come to the chemical structure of polymer, there are two groups that I said. The first group are polyolefin that does not have functional group in the backbone. So this is quite challenging to make chemical recycling to them. But for polyester that have ester group in the chain, so this is quite easy to break the chain down into small molecule as a product. And the one that I will give example today, polylactide or PLA, I think anyone who are in the degradable polymer field should know this quite well. This is one of the very popular polyester that can be degraded after use. The polymer can be synthesized from sugar or starch by fermentation, making lactic acid, which is monomer. And then we can convert this monomer into polymer by two different ways, ring opening polymerization or polycondensation. And finally, we have the polymer that is degradable after use. However, in our point of view, we think that in order to make this just degrade and turn to CO2, why don't we just convert them into like a starting material again, and then we can make them to use to make other products that have a value-added applications. So what we do is we apply the concept of chemical recycling here by using microwave reactor and using the reaction that is called alcoholysis. So we will break the chain of this polymer, which have ester group by alcohol or OH groups. And in order to use this as starting material for other products, so the final product should have two functional groups at the end. So therefore, we need to react this polymer with at least diol, which contain two OH group or more than two, like 3, 4, 5, 6. So we use different type of alcohol in this type of reaction. And from this process, it takes only about 10 minutes to digest the big chain of PLA into small unit, completely in only about 10 minutes of reaction. So this is very effective. So if we want to make this as standard technique, we need to know the mechanism of the reaction. So at the same time that we develop the process, we also develop characterization techniques in order to know in detail about the mechanism of this reaction. And the one that we use here is FTIR or Fourier transform infrared spectroscopy. So we study this in detail. In every system, we vary the ratio between PLA and also alcohol. We vary the time, we vary the type of the alcohol, and then we look at the structure of the final products. For example, here, if we look at this peak right here, this peak, the intensity of this peak can tell us the length of the final products. If the intensity is very low like this, it means it is very short product. So it can mean we can convert the product into monomer, which is 1 unit long only. But if this peak have high intensity, it means our product is quite long in the length of the final products. That is one example that we can do. And we can apply this to different type of system. We have, we can study the mechanism of them. Also, we can look at, we can use this, set this up as quantitative analysis. So we can measure the content of each product in the system. And also we can monitor how much alcohol is remaining or unreacted in the system as well by using the result from FTIR, quantitative analysis. And another surprising result that we observe, actually, in our objective, we just want to break down the polymer chain into smaller units. However, we also produce what we call lactide, which is dimer of lactic acid. It has ring structure like this from the reactions. And this is very, very important because the lactide here can be used as starting material to reproduce polylactide again. And so if we can convert PLA waste and then convert them directly in polylactide, this is very, very useful. And we can control how much lactide we obtain from the reaction. So by using FTIR quantitative analysis, so we can take the spectrum of the products, and we can take spectrum of standard solution. We can make standard curve and then look at our products, so we can quantify how much lactide are produced in each system that we have conducted in the chemical recycling process. So basically, if you look at this plot, you can see that if we change the ratio between the polymer, PLA, per alcohol from the beginning, we can, if we increase this ratio to higher and higher ratio, we see that we have higher and higher amount of lactide produced from in the system. So we can have this right now almost go to around 10% of lactide that are produced at the end. And also, even though lactide is very surprising, very surprise product that we obtain, but our main target is we want to make the product that is look like this. So we break down the structure of PLA, and then this react with the alcohol that we add into the system. So there are different type of product that we obtain at the end. So if the alcohol only react, right, by using one OH group to react, so we still have one OH group free remaining in the structure. So we call this structure A. And this structure A also have different length or different repeat unit. So if this is only one, it means it is very short. So if this, we have 2, 3, 4 repeat unit in the structure, it means the product is longer and longer. So we can vary this, right? And the other structure of the product is if one alcohol react, the other also react with PLA. So the alcohol react on both ends. So we have one end that is lactate, or the other end is also lactate here. And the size of this also vary as well. We can control how much we want. So, however, all of this structure, if you look at the end, they have OH group at the end chain. So we can use them as what we call polyol starting materials for other applications. And because we have a mixture of this as a product, therefore it is very important to quantify these products. So we need to know exactly how much of each structure we have. Therefore, we need to know the structure in a very fine detail. And to do that, we apply two-dimensional NMR to look at the structure. And at the ends, when we have the result from 2D NMR, we can have a very precise peak assignment. And after that, we come back to proton NMR spectra of the products, and then we can do quantitative analysis. So at the end, we will have a summary like this one here. If you look from this graph, we can quantify how much of each type of product we have at the end. If we use a ratio of 1:1, 2:1, 3:1, or 3:4, for example. And this is the yield. The blue one is the shortest, the product with the shortest sequence, which have only one lactate. The red color is the longer one, 2 units. And the green one is longer than 2, so we call this polylactate, for example. And you can see that we can vary if we have very, very short amount, very short products. So we want very high amount of blue color. If we want product with 2 units, we want the red color. If we want longer than that, the product longer than that, we want green product, for example. and we can vary the condition to obtain this product. And from this picture here, I just introduced that the products have two different structures, right? The first one OH group react, the other one is still free. We call structure A. And if both OH group react, so we have what we call structure B. But in the system, we also use alcohol that are more than 2, right? If all of the alcohol react, so we call this structure C, for example. So structure A is represented by blue color, structure B, red color, structure C, green color. So now we can vary the ratio in order to obtain product with different composition. And product with different composition here can be used for different applications. So that is for PLA, but for PET, right? This is very popular products. We also apply similar process to break down the chain of PET into a small molecule. And then we can make them into starting material for other application. For example, in this structure, we react this with MAAH to introduce double bond into the molecules. So once we have double bond in the molecule, we can use this as monomer. We can synthesize this into copolymer, for example, a big chain polymer. So we can have the product from PLA, chemical recycling of PLA and chemical recycling of PET, and make them react with each other. We have what we call aliphatic aromatic copolyester. So this type of polymer has very strong mechanical properties, but can be degraded after use. So this combines the benefit of PLA and also benefit of PET together to have our final products. Another promising product that we can get from the chemical recycling product is we just use the chemical recycling product here as starting material that is called polyol in the synthesis of polyurethane. And this type of polyurethane can have very good mechanical properties, but can be degraded after use because they are made from degradable polymers. So what we use here is we react our products here with diisocyanate to generate polyurethane, which have the structure look like this. And these are example of potential of application of this polyurethane that we get from PLA. So the first one is called shape memorized polyurethane. So when we make this polyurethane, we can make them into their original shape by heating them up at temperature higher than the TG. For example, this one here, you can see when we put this back into an oven of around 60 degrees Celsius, so they turn back to linear structure. So this is called shape memorized polyurethane. Or we can use this as toughening agent. So for PLA, we know that PLA is brittle. So if we look at mechanical properties, PLA can break very, very early, around 4% of elongation. However, if we add our polyurethane into this PLA, we can make it, right, go very, very long before breaking, right? So elongation can increase to more than 100% if you look. So these are some potential, high potential application of the polyurethane that we obtain from chemical recycling of PLA. And we can make them into various type of product, especially 3D printing filament and also degradable adhesive. This type of product is very, very sticky, so we can use them as glue. This is another application of the chemical recycling product that we get from PET. we can convert this and make this into what we call metal organic framework or MOF. And this type of materials is porous material that have various type of applications. And one example here, we just introduce this back into PLA, and this can improve mechanical properties of PLA, for example. But this can be used in other environmental application as well. They can be used as absorbent for various type of metal ions in water system, for example. So that are the first part that concerned with chemical recycling process. The second part that I will talk about is making polymeric micro or nanoparticles. So by using this type of technique, we can use the material in various applications in biomedical, cosmetic, coating, food, in various applications. And this field is very, very attractive. Many people work on this field. However, if we make micro or nanoparticle from normal polymer that cannot be degraded, this can cause serious problem to the environment because they are very tiny particles that cannot be degraded. So they contaminated in water, especially in marine system. So that is not good. However, if we use if we make micro or nanoparticles here from polymer that are degradable, so we can use them for the same application. However, after use, we can all of these particles can be degraded, so they will not cause the same problem with existing products. We use many different polymers to make micro or nanoparticles here. And one of the examples that I want to show everyone here is a copolymer from PLA, polylactic acid, and GMA, which have double bond in the molecules. So at the end, we have copolymer that look like this. And so if we use this polymer to make micro or nanoparticles, they can be degraded after use. However, the good thing about this is they also have double bond in the molecules. So we can cross-link this polymer to make them even stronger. So as a result, we also use them to make different type of particles. And we also study the process to make the particle have different structure. For example, we can make the structure to be solid particles, or we can make hollow particles, right? By varying the process. If we want to make hollow particle like this, we need to introduce PLA into the system. For example, we have hollow structure. And we study the mechanism in detail as well. We also can make morphology, right? Can vary the morphology. So make them very, very smooth like this, or make rough surface like this. So this is a result from different cross-linking time. So if we cross-link the polymer at shorter time, so this feature is crystalline domain of the polymer. So if we have less cross-link, so we have more crystal. So we have rough surface. However, if we cross-link the polymer at longer and longer time, we have more cross-link structure. So it means we have less crystal. So we do not have the pattern like this anymore. So the structure, the morphology here is very, very smooth. So we can use this as scrub bead in cosmetic application. And also because the particles here is hollow, so we can encapsulate some active chemical inside the particles. So for example, we can encapsulate like various type of drug or herb. This is traditional Thai herb that we call Pla inside the particles. We can encapsulate some essential oils into the particles, different type of them. And this is another example that we can make micro or nanoparticles from chitosan co-PLA copolymer. So we modify the structure of chitosan by grafting PLA onto the structure of chitosan and then encapsulate drug inside here that also consists of magnetic nanoparticles. So this can be used for drug control release applications. On top of that, we can further modify the surface of the particles. Everyone might know already that if we want this to be to have antimicrobial properties, we need to introduce high density of charge on the surface. So we can react this particle, modify the surface by reacting with GTMAC that have positive charge right here into the structure. So at the end, this show very good antibacterial properties, both gram-negative and gram-positive bacteria. Now, when they show antimicrobial properties, but if you want to use them for biomedical application or food contact application, we also concerned with cytotoxicity of the materials. So we measure cytotoxicity of the materials, and if you look cell survival of on the material up to 1,000 microgram per milliliter are comparable, right? So 100%. So it means that this material is not toxic to the cell. However, they show antimicrobial or antibacterial properties. So they can be safely used in biomedical applications. Or some other system, we also can apply them on packaging film. So we make particles that have antimicrobial properties that, and then we just attach this on the surface of the film, and we can use them for food packaging. So if we look at SEM picture here, so these are the surface of PE film, and then we just deposit our particles on the surface, and these particles show antimicrobial properties. So these are some examples of the research that we focus on micro and nanoparticle from polymers. And the last part that I want to share with everyone today here is the development of bio-based compounds. So this may not be a big molecule or polymer, but they are small molecules that come from bio-based. And the application for this are for anti-scalant in water cooling system, especially power plant system. So the existing materials that are used in this system are usually this polymer, polyacrylic acid, or PBTC. But these are not friendly to the environment. So if this compound are discharged into water resource, they cause lots of problems to the environment. So it should be better if we can replace these compounds by bio-based materials or bio-based compound, but show the similar properties. Material that can show anti-scalant properties should have high density of charge on the structure. So that's why we develop material that come from chitosan. This is structure of chitosan. Actually, the native chitosan can have positive charge in the structure by protonation of this NH2. If we dissolve this chitosan in acid condition, they have positive charge. However, this is not quite effective. We want to introduce permanent positive charge into the structure. So we just react chitosan with GTMAC. At the end, so we have chitosan structure that have permanent positive charge, and we can control how much positive charge we want on the chain, right? And this is called quaternized chitosan or QC. And when we want to use this in many applications, we can make them into particles, micro nanoparticles. We can cross-link them by TPP, which have negative charge, for example. So this have many applications. So not only introducing positive charge, we also want to introduce permanent negative charge to the structure as well. So what we do is we can oxidize OH group right here into carboxylic acid group that can protonate and become carboxylate group that have negative charge. So if we have this structure, right, our chitosan now have both positive and negative charge on the same chain. So this is called polyamphylite, or we call CPA. And this can work very well as anti-scalant compound. So we developed the process to produce this compound. And also at the same time, like I said, we need to know the mechanism very well as well. So we apply the concept that is called two-dimensional correlation spectroscopy in order to study mechanism, what is going on during the reaction. So if we know very well, we can control the structure of the product very well. And as a result, we have the chitosan-based anti-scalant that work very well. This is the performance on anti-scaling. If you look, you can see our CPA, which have both positive charge and negative charge, work very well, almost 100% anti-scaling performance. If we compare this to existing chemical, which is in this group, PBTC, AAM, or PMA, for example. Not only calcium carbonate, we also test calcium sulfate. Right? This is also very good performance if you look. And also we look at the morphology of the scale. And after we introduce our anti-scalant, the morphology of the scale change, right, depends on the structure. So this study by SEM. So this is 3 examples that I want to show with everyone today that of our research work that concern with degradable polymer and can be used in a sustainable way. So finally, I would like to summarize what today that is called alcoholysis. And at the end, we can use this chemical recycling products to make them into new materials that have high value, and also we call functional materials, and use them in many applications. This is the first part. And the second part is we focus on the use, the development of process for micro or nanoparticles fabrication and the use, and they can be used in many applications widely. And the last part, I talk about the bio-based chemicals, especially for anti-scalants and anti-fouling applications, and they are friendly to the environment, which can be the alternative to replace the chemicals that are used in the process, existing one. And finally, I would like to thank the granting agency who provide the supporting grant for us to conduct this research work, and also the member, the students, like collaborators in our groups. And I thank everyone for your kind attention, and I would very happy to answer if there are any questions. So thank you very much.
Welcome.
Thank you so much, Professor Pakorn, for a very interesting and informative presentation. So many of us don't realize that so many application of the polymer composite materials in our life. So this is a very good updates on what these composite polymers can be applied in many fields. So for the question and
Yes.
answer session, it will be in the last session. So after the second speaker, so
Sure. Yes.
we hope that you would kindly wait until the last session for the question and
Yes,
answer.
I will. I will. Yes.
So now we can proceed to the second speaker. The second speaker is Dr. Muhammad Nasir. He's belong to the research unit for clean technology in Indonesian Institute of Science. Welcome, Dr. Muhammad Nasir. Is Dr. Muhammad Nasir already here? I think I saw him before. Pak Nasir,
Yeah,
are you here? Okay, so I would like to read the CV of Dr. Muhammad Nasir. So his education and he got his bachelor degree from in the chemistry department of Universitas Andalas, and then the master degree from in chemistry department from Institut Teknologi Bandung, and then his doctoral degree in organic and polymer material from Tokyo Institute of Technology. The title of his presentation today is about nanofiber composite, fundamentals and applications. Dr. Muhammad Nasir, have you joined us now?
okay. You hear my voice?
Okay, yes, it's clear, Dr. Muhammad Nasir, it's very clear. So you can start to
Okay.
share your screen now. Thank you so much. The time is yours.
Okay. Thank you very much, Chair. Good afternoon, ladies and gentlemen. I'm very glad to join with you all, especially in this conference, current progress in polymer composite science and technology. Today, we will share our research about the nanofiber composite fundamental and application. This research was conducted in Indonesian Institute of Science in our research group, Environmental Nanotechnology Research Group. Okay, this is outline of my presentation today. The first introduction, and then nanofiber, and the current status of nanofiber research in the world, and process to produce nanofiber composite by electrospinning process, and then we introduce some application of nanofiber composite and conclusion and future outlook. Okay, our main office is located in Jakarta, but our laboratory in the Bandung city. This is our main office in Jakarta. Okay, as you know, everyone in the world want to get a high quality in life by two aspects: spiritual and material or physical aspect. In the perspective of material and physical aspect, the technology and material is very important. But what happened when we use conventional technology to get human needs? You can see here the pollution in the land, in the air, and also you can see here when we use conventional technology, you can see the man use the big phone for his daily life. Thanks to nanotechnology, by using nanotechnology, we can improve the quality human life, and we can go to minimize the waste in the planets. You can see here when we use nanotechnology, for example, in the energy storage, we can use, people can use the free pollution of the car, electric vehicle. And also now by using nanotechnology, for example, in the semiconductor, you can see we can use the smartphone, very small smartphone with high functionality. So by using nanotechnology, when we move from the conventional technology to green nanotechnology, we can go to the zero-waste planets. Okay, this is nanomaterial in our daily life. For example, you can see here the water molecule is size is around 0.037 nanometer, virus around 100 nanometer, bacteria around the 500 nanometer, and also you can see here the advancing in the semiconductor technology. Now the people can make a transistor in the size of the 7 nanometer. This is our nanotechnology in our daily life. Okay, I will introduce you what is nanofiber. Nanofiber is fiber with diameter less than 1 micrometer or 1,000. Or some people said nanofiber is fiber with diameter around 100 nanometer. But in the fiber society, they said nanofiber is fiber with diameter less than 1 micrometer. This is an example of the nanofiber. You can see here, this is morphology of nanofiber. And when we use the field emission scanning electron microscopy, we can get a beautiful surface of nanofiber. You can see here. Okay, the question is, who is the main player research in the nanofiber in the world? You can see here, there is 4 main players of nanofiber research in the world. USA, China, Japan, and Korea. You can see in this graph. And then how many publications of nanofiber in the main publisher? There is 50,000 nanofiber publication in 2020. It's very, very high publication. It means this topic is very hot in the scientific aspect and industrial aspect. You can see here in the Elsevier, the main researcher published the work in the electrochemical acta and carbon. In the ACS, American Chemical Society, they published the work in the material science and nanoscience. We can see the focus of the people where they publish the work. And then the question is, how many % of the nanofiber composite research in the world now? When we see in the Science Direct, we can see here, around 64% nanofiber research is about nanofiber composite. It means nanofiber composite is very important for application and all for scientific point of view. You can see here. Okay, now we talk about what is the application of nanofiber to improve the quality of human life. You can see here, nanofiber can be used in the security and defense. For example, to develop the sensors. And then nanofiber also can be used to develop energy storage, for example, separator in the lithium ion battery. And also nanofiber we can develop for application in the environmental application, water treatment, treatment, aerosol. This is an example. And then important one is the application of nanofiber in the fashion. We can make a smooth fashion look like silk. And nanofiber also can be used in medicine, for example, in drug delivery, and also in biotechnology, in tissue engineering. Okay, how we make nanofiber? There is many methods to make nanofiber, but one of the simple procedure to make nanofiber is by using electrospinning process. We can use single nozzle or cisco electrospinning or coaxial electrospinning. The principle of electrospinning to make nanofiber is very simple. We use a DC electrical current, high voltage. This mechanism is follow charging of polymer solution, concept formation, you can see here, concept formation, and strike jet formation, bending instability, and solidification of polymer jet. So by using electrospinning process, we can make two types of the nanofiber. We can make random nanofiber, for example here, we can make a random nanofiber, and also we can make a line nanofiber. If we use the high-speed drum collector, this is a parameter to make a nanofiber by using electrospinning process. Okay, this is example electrospinning machine to produce nanofiber. Okay, the important point when we make nanofiber by using electrospinning is how we make homogeneous electrospinning solution. For example, if we want to make a polymer nanofiber composite, first we use polymer in powder or pellet form, nanoparticle in powder, and solvent. We mix it by mixing and heating, and then we wait until all of polymer is dissolved in the solvent. After that, we must remove the air bubble in electrospinning solution. After that, we can use the polymer solution to make nanofiber composite. Okay, to make nanofiber composite by using electrospinning, there is two main techniques. You can see here, we can use single nozzle electrospinning. It means we use the single polymer solution feed, only one polymer. And second is when we make nanofiber composite by using coaxial electrospinning, we can make two polymer solution. Polymer solution feed 1 and polymer solution feed 2. So this is method to make nanofiber composite by electrospinning. Okay, this is example of nanofiber composite when we make by using single nozzle electrospinning. You can see here we can make a carbon quantum dot polyvinyl alcohol nanofiber composite. First, we synthesize carbon quantum dot by microwave technique, and then we make a PVA, polyvinyl alcohol, and quantum carbon dot solution, and then we do the electrospinning process. Here you can see the morphology of the polyvinyl alcohol nanofiber. You can see here it's a good polymer solution. You can see here we can get the very smooth and homogeneous nanofiber with diameter around 229 nanometer. And for the composite, in the optimum condition, we can get the smooth quantum carbon dot PVA nanofiber composite with diameter around 223 nanometer. What happened in the surface? You can see here water contact angle of the PVA. PVA is a hydrophilic polymer. You can see here the water contact angle is around 65. When we add quantum carbon dots, the water contact angle is around 52. It means we can make more hydrophilic nanofiber composite, quantum carbon dot polyvinyl alcohol nanofiber composite. This is example. And then also by using single nozzle electrospinning, we can make light sensitive graphene, titanium dioxide, co-PVDF nanofiber composite. You can see here we can combine two nano material, graphene and titanium dioxide. We make a polymer solution by using PVDF, and then we use organic solvent, and then we mix it, and then we can make a nanofiber composite, like sensitive graphene, titanium dioxide, co-PVDF nanofiber composite. By using SEM EDX, scanning electron microscopy EDS, you can see here, this is the distribution of fluorine atom in the nanofiber. And here you can see the carbon, and then we can see the titanium distribution in the nanofiber composite. You can see the yellow point is titanium. And also when we see in the transmission electron microscopy, we can observe the nanoparticle in the nanofiber composite. Okay, now how to make nanofiber by using coaxial electrospinning composite. In this case, we try to make a PVDF PMMA nanofiber composite. You can see here, fit solution, one is PVDF, and second fit polymer solution is PMMA. Now you can see here, we can make, in the core is PVDF, and in the shell is PMMA. So by using this technique, we can make more complex nanofiber composite. Okay, now we try to see what is application of nanofiber for clean energy. In this case, we try to make to develop the silicon dioxide co-PVDF nanofiber composite. Okay, as you know, energy is a primary need of the human, but all of energy we use is come from the fossil. What happened to our Earth? You can see here around 72% of the energy will give effect to the greenhouse effect. It means our Earth full with the carbon dioxide. So researchers and industry try to how to solve this problem. You can see now the people try to develop the energy storage. For example, lithium ion battery in electric vehicle, for example, for car or for airplane. So the key technology in the lithium ion battery is anode, cathode, and also the separator. So in this case, we developed the nano separator by using silicon dioxide co-PVDF nanofiber. You can see here the mechanism of the separator, how separator make a good lithium ion battery. And the important point when we develop the lithium ion battery separator is how we make thermal stable and thermal oxidative stability of the separator in elevated temperature. So this is a point of the nanoparticle in the nano composite of separator. So we try to make a nanofiber composite with different of the silica. You can see here we try to increase the concentration of silica in the nanofiber from 0.5% to 1%. You can see here when the increase of silica content in the nanofiber, the nanofiber diameter is decreased. Okay, so we observe the silica co-PVDF nanofiber composite by using FDS spectra. By using infrared spectra, we can also observe the crystal phase of the polymer, for example, PVDF, because PVDF or PVDF copolymer is polymorph. So we can see here in the FDS spectra, but the polymer has alpha and beta phase crystal structure. You can see here, this is alpha phase, and here is beta phase. And then we confirm by using X-ray, XRD. You can see here, this is beta phase crystal structure, and this is actin is alpha phase. So it means in the composite, crystal structure of PVDF is a mix of alpha and beta phase. Okay, what is the effect of the nanoparticle on the crystallinity? You can see here, increase of the silica content, decrease in the crystallinity of the polymer. Okay, and then we try to see effect of the silica on the wettability of separator. You can see here, increase of the silica, increase the water contact angle. It means the nanofiber more hydrophobic than pristine co-PVDF. Okay, this is an important point when we develop the separator. The thermal behavior we measure by using TGA. You can see here effect of the silica on the degradation of the polymer composite. You can see in pristine PVDF, they start from the 420, but in the composite, the initial degradation is around 440 centigrade. It means we can control the thermal property by adding the nanoparticle. And also, why we study the degradation in oxygen. This is very important. When there is a shortcut happen in the battery, so we can see by using silica nanoparticle composite or nanoparticle, we can control more safe separator. Okay, this is, you can see here. As we know, commercial separator is people use cell guard. This made from you can see the shrinkage after heat treatment around the 70%. For pristine PVDF separator, the shrinkage is around 61%. And then for nanocomposite, you can see here the shrinkage of the around 42%. In another composition and formulation, you can see the 34%. It means the presence of silica nanoparticle in the separator, we can get more heat stable of the separator. So we can, this is a good candidate if you use in separator in lithium ion battery. Okay, now we want to talk about the application of nanofiber for medicine and biotechnology. In this case, we try to develop nanofiber by using dragon blood resin. Dragon blood resin with polycaprolactone nanofiber composite. Okay, As you know, around 8 million people had one with or without infection. And amazingly, cost estimate for acute and chronic wound treatment around 2028 to 96 billion. So this is very important in perspective of the quality of life and the economy aspect. And then the question is how wound dressing can protect the wound, skin wound. You can see here bacteria, virus, fungi, dust can be cannot enter the skin wound. So you can see the wound dressing is barrier for this material. And then the important one is how to manage the thermal, air, and water management in the wound. And then how the wound is can we do the healing in the wound. Okay. Now, this is property of dragon blood. It has antibacterial and antivirus property, and the polycaprolactone has biodegradable and biocompatible. Now, we can see here the morphology of polycaprolactone nanofiber. We can see here, we can make nanofiber without bead from concentration 15% to 90%. You can see here increase of polymer concentration will increase the fiber diameter. This is related with effect of the viscosity of polymer solution. Now we try to make dragon blood resin PCl polycaprolactone nanofiber composite with different dragon blood composition. You can see here effect of the dragon blood on the morphology and diameter of nanofiber. You can see here increase of the dragon blood concentration. The concentration diameter of nanofiber is increased. And then we try to measure how effective this nanocomposite dragon blood PCl nanofiber composite to inhibit the bacteria. We try to measure this property by using inhibition zone and inhibition zone and TPC method. You can see here the nanofiber composite is active to inhibit E. coli and S. aureus bacteria. It means from this result, this composite dragon blood polycaprolactone nanofiber composite is a good candidate for wound dressing application. At the end, I want to introduce the application of nanofiber composite for environmental application. In this case, we try one of composition, copper oxide, co-PVDF nanofiber for nanomass. As you know, based on the World Health Organization, United Nations, around 7 million people death every year as effect of air pollution. And main pollutant is virus, bacteria, and particulate matter. This occur in the indoor and outdoor. Now we have there is a corona, COVID-19 virus in the air that infect the human. This is a long history of the pandemic virus. You can see here, In Russia, 1 million people dies. And then in Spanish flu, around 100 million people dies. And then in avian flu, around 1 million people also die. And then swine flu in around 2010, around 150,000 people dies. And then COVID-19 virus, almost 500,000 people dies. So how we protect human from this pandemic, virus pandemic? So we can use nanofiber composite to protect people from the air pollution from particulate, bacteria, and virus. You can see here illustration of effect if we use mask and if we not use the mask. The mask, protective mask is membrane, semi-permeable membrane. You can see here how the membrane works to inhibit the particle, microorganism, and chemical. Okay, there is two types of face mask we can use from the COVID-19. We can use medical face mask, and also we can use N95 mask. We can use both of them. Okay, this is property of the copper oxide co-PVDF nanofiber composite. You can see the advantage, the main advantage of co-PVDF polymer is its piezoelectric property. It has electrostatic property. And then the advantage of copper oxide is it has antivirus and also antibacterial activity. So when we combine this, so we can make a good mask to protect man from the virus or bacteria. So this is we can see how we can make copper oxide co-PVDF nanofiber composite. You can see here. This without copper oxide, we can make a smooth nanofiber. But by adding the copper oxide, you can see here the agglomeration of nanoparticle on the surface of nanofiber. And then what happened? The effect of the copper oxide on the size of nanofiber. You can see here increase of copper oxide content in the nanofiber composite. So the diameter of nanofiber is decreased. Okay, and then we evaluate effect of the copper oxide nanoparticle on the crystal structure of the PVDF. You can see here we focus on the alpha and beta phase crystal structure because this property is very important in the application in the mask. You can see here this is mix of beta and alpha crystal phase in the composite, in the polymer. And then the same result you can see here. This is around 2 theta, around 22 is 20 is about beta phase, and 18 is alpha phase. So the crystal structure is a mix of the alpha and beta, but it's dominantly beta phase. Okay, another important property is the hydrophobic property of this material, this nanofiber composite. We can, because this is very important, if there is droplet of the virus, for example, COVID-19 virus, the hydrophobic material of mask is very good to protect people from the virus droplet. So you can see here, our nanocomposite, copper oxide, copy wave nanofiber composite is show the hydrophobic character. You can see here, water contact angle and water spreading time. So it means it can repellent the water droplet. And then we try to, we want to see the antibacterial property of this material. You can see here, it's very good. It's active to inhibit and kill the bacteria. And this is E. coli. So how we evaluate the performance of mask? The main parameter is collection efficiency and pressure drop. These two parameters to evaluate the mask. This is standard for mask. You can see here, bacterial filtration efficiency, BFA, differential pressure, submicron particle filtration efficiency, and resistance to penetration by synthetic blood. This is main parameter when we study the mask. You can see here, this is commercial mask available in the market. It's made by microfiber. It also shows the hydrophobic character. This is a nanofiber mask. You can see here, this is more hydrophobic than the commercial mask. Okay, now we can see the performance of the mask. You can see here, this is commercial of mask. You can see this is PM 0.3 micrometer, and the green one is the PM10, 10 micrometer. You can see here, this is collection efficiency of commercial mask. This is our nano mask with different composition here, with different formula. You can see here, the performance of the nano mask is much better than the conventional. And then when we measure the air permeability of the mask, you can see here, this is a commercial mask. The air permeability around 48, and the nano mask is, there is 90, 60, and 70. It means nano mask is breathable, more breathable than the commercial mask. We can explain by this graph. You can see here in the nano mask, the airflow is not zero in the fiber surface. This is slip flow effect. But in the microfiber mask, the airflow rate is zero on the fiber surface. So why we can get this result? And then important one is the electrostatic attraction in our material, because we use the piezoelectric material, which have the beta phase crystal structure. So we can get better collection efficiency than the conventional mask. So this is an example of nano mask based on the copper oxide, copy wave nanofiber composite, and we try to develop some formula of nanofiber composite depend on our need. Okay, in conclusion, nanofiber composite have many applications. In the near future, it will contribute in improving the quality of human life and to minimize the waste, because we use small material and green material, and there is still room and challenging in developing of new nanofiber composite, its application and its mass production. At the end, Thank you very much for your attention, and all our member in environmental nanotechnology research group, and also for Indonesian government for financial support for this research from Indonesian Institute of Science, from Ristek Brain, and also from Rispro LPDP. Okay, thank you very much for your attention.
Welcome.
Okay, thank you so much, Dr. Nasir, for a very informative and insightful presentation. So I can conclude that Dr. Nasir present about the many application of fiber composite, and then the latest application it can actually be applied as the alternative mask during the COVID-19 pandemic. So now we come to the question and answer session, and I have received many questions for the two speakers. I will read the first question now. So Professor Pakorn, are you ready? I'm going to read the first question for you. It is from
Sure.
Muhammad
Yeah.
from University Muhammadiyah, Sumatera Utara. As we know that plastic is very hard to degrade in nature. So usually we use sort of a gasification method to result a liquid fuel from plastic, but I believe it takes a long process and very expensive cost. Can you mention or some alternative technology that we use as an alternative way to degrade the plastic waste? Thank you.
Okay, thank you. Like I said, from my presentations, we can classify plastic into two groups. The one with functional group, especially polyester, can be easily to chemical recycling, break down the chain into small molecule, and by various type of reaction, right? Reacting with alcohol or amine, this can be the effective one, especially using microwave as a heat source. We can use only around 10 minutes to break down everything to the smallest unit as a product. But the more challenging one, which we also study as well, are polyolefin, for example, polyethylene, polypropylene, polystyrene. This does not have functional groups in the backbone. So it's quite hard to break this down, and it is quite common to do pyrolysis, right, to make this into small molecule. However, the product will not have functional groups and cannot be used for other application later on. So what we do is we use the reaction that is called oxidative degradation. So this is different from pyrolysis because we break down the chain and also introduce functional groups into the products, especially OH group or carboxylic acid groups. So the oxidative degradation here will give the final products that have functional group that are suitable for making polyester, for example. And what we can do now, we use a reaction in hydrothermals, right? We need to apply high pressure with strong acid in the reaction, and we can break down chain of polyolefin. It is promising. In our lab, we can do this in small scale already, but now we try to develop this into a bigger scale production. Yeah, so we can say that for the polyester group, it is very established technology already. But for polyolefin, still need more further development. Yes.
Yeah. Yeah. So for polyester, you mentioned there's so many available technology to degrade polyester, but for olefins, there's still some challenges ahead. Yeah.
Right.
Okay.
Yes.
Yeah. Thank you. For the second question, Professor Pakorn, is from Fikri Nur Ramdan from Universitas Garut. Can you mention the side effect of the use of antimicrobes? Is there any side effects of the use of antimicrobials?
Okay. Yeah, it's quite hard to answer that question. Right? It depends on, because when we talk about chemicals that have antimicrobial properties, there can be various types of compound that can have that properties. But in our lab, we focus on the compound that come from Biobase that may have lower antimicrobial properties than the drug, for example, antimicrobial drug. However, they are safer to use in many applications. And also, because they are natural based, we just extract them from some plants or from bacteria or fungi, for example. And they should not have any type of inverse effect to the application or to the environment. Yeah, to answer that question, I think it depends on what we are talking about. But in our research, we try to focus on the one that are from bio-based. So there should not be any problem with them.
So the one from bio-based materials should be safer for the environment as well, right?
Exactly. Yes. Yes.
Yeah. Okay. So the third question: do you use monomer for PLA from plants in your research?
Right.
Sorry?
Yeah. Actually, PLA come from lactic acid, which is product from fermentation of sugar or starch, and we mainly use lactic acid from fermentation, like from plants. But I only showed the part that we get this from chemical recycling, right? But normally in our lab, like when we make copolymer of PLA, we use lactic acid monomer from plants. Yes.
If you're going to cross-link the PLA with cellulose, what is the most suitable cross-linker? If you're going to cross-link the PLA with cellulose, what is the most suitable cross-linker?
Cross-link with cellulose. Okay, if we want to do in molecular level, right? The cellulose have OH functional groups. So if we have like diisocyanate, right? We need something to help. PLA also have, we can functionalize PLA to have OH group as well. So and cellulose have OH group. So then we can use chemical that can react with OH group very, very fast, like epoxide group, or isocyanate that have the compound that have more than one functional group in the molecule should be able to cross-link cellulose with PLA effectively for molecular level. But from my point of view, I do not see the benefit of doing that, right? We may want to use cellulose in the form of nano or microfiber and use this to generate composite with PLA. That is more common. We may not need to go to molecular level, I think. for cellulose.
Okay. Yeah. Okay. Thank you, Professor Pakon. We still have some question. It is from Ibu Dr. Fitri Dara from Indonesian Institute of Science. Is polymer used in your research are laboratory grade? Is there any problem if we try to degrade the polymer such as the PLA? Can you understand?
I'm sorry, I cannot catch the first part correctly. Could you please repeat the first part again?
She's asking if the polymer that you use in your research is laboratory grade or PA, or is it like technical grade?
Oh,
the
okay.
Polymer. And then
Yes.
Do you have some problem when you degrade items made of polymer like PLA?
Okay. We try to chemical recycling PLA. We started with original resin of PLA because we want to know the mechanism, right, in a precise way. So we want to study in deep detail of the mechanism. However, the process can be applied to normal product, commercial grade, the same way. And we do not need to make them so the final product to have like high purity, because especially if we want to use them as only degradable glue or making polyurethane from the chemical recycling product, there is no problem with the original source of the materials. Doesn't matter if it is commercial grade or not. And we don't need to purify them. We just use them directly after completing the chemical reaction.
Yeah.
And the second question was what?
The second question is, do you face any problem when degrade items made of polymers such as PLA? Is there problem while degrading this kind of polymers?
No. Actually, especially for PLA, this is very clean reaction. No toxic chemical releasing, except polyolefin, right? And if you want to do oxidative degradation of polystyrene or polyethylene, for example, we need to use very strong acid in the reaction, and we need to develop the way to recover the acid or to prevent the leak of the acid to the environment, something like that. But for polyester family, there should not be any problems.
Yeah. Okay. So I think we reached the last question for you. So since in Indonesia we have this government policy that most of our research needs to be headed towards the COVID-19 problems. So do you have any research in your lab that is actually dedicated to this problem during the COVID-19 pandemic?
Okay, very good. Yes, actually, there are some work that we also develop materials to cope with the COVID-19 situation. Some example, we develop actually face mask as well, right, from electrospinning, and also we functionalize the surface of the nanofiber. Also, we decorate the surface by nanoparticles that encapsulate antimicrobial compound, and that can sustainable release the compound, something like that. That is one example. Also, we, apart from encapsulation of antimicrobial materials, we also treat surface of materials to achieve super hydrophobic, right? super hydrophobic mass is also one of our achievement. Actually, we develop emulsions of hydrophobic agent that we can just spray onto normal fabric, especially natural fabrics that have OH group. Our emulsions, right, will penetrate onto the fiber and form covalent bond with the OH group of the fiber, and then make the fiber have super hydrophobic properties. So aerosol cannot stick onto the face mask, something like this. So these are two examples that are related to COVID-19 situation that we recently work on. Yes.
Yeah, thank you so much, Professor Pakorn.
Sure.
Yeah, I'm moving to the next speaker. There are some questions also for Dr. Nasir. One is from Amalia Kartikasari. She is a student from the chemistry department of UIN Alor Makassar. Her question is if polymers, the side effect of polymer and how to deal with that effects.
Can you repeat the question?
Yeah. What is the bad effect of using polymer, and then how to deal with that?
Okay. 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 I think this is a good question. In the industrial perspective, in some application, we need a polymer with long lifetime. But in some case, we need a polymer with a short lifetime. So this is depend on the application of the polymer. So we can, for example, when we use the polymer in automotive, so we need more stable polymer. So we can, so if you use the unstable polymer, so the lifetime of the product is not so good. So this is a very important thing. But in the case when we use the polymer in the packaging application, so we need a short lifetime of polymer. I think this we can choose for what we use the polymer. Okay.
Okay. Yeah. The second question, Pak Nasir, is from M. Yani from Universitas Muhammadiyah Sumatera Utara. How can we obtain nanofiber material in Indonesia? Can we obtain it from a natural source like coconut fiber or the pineapple leaves?
Yes, we can. There is two type of fiber: synthetic fiber and the natural fiber. Also, there is a natural nanofiber and also the synthetic nanofiber. So, in the case of natural fiber, so we can make natural nanofiber from the natural fiber. For example, we can make it from the we can make from the coconut, banana fiber, and so on. But there is we should use the some equipment. For example, we can make a natural nanofiber from the natural fiber by using the chemical method, or by using the ultrasonic process, or by using high pressure homogenizer. So yes, of course, we can make a nanofiber or microfiber from the nature.
The third question, from Dr. Fitri from UPI, the addition of CuO on nanofiber led to the reduction of nanofiber size. What was actually the mechanism occur on that interaction?
Okay, as we know, the effect of nanomaterial can give a lubrication effect. So some of nanoparticle we can use a nanoparticle to control the viscosity of the polymer. So in this case, the copper oxide nanoparticle act like the lubricant. So the viscosity of polymer solution will decrease. It means by using electrospinning process, if the viscosity of the polymer decrease, we can make the small diameter of nanofiber.
Yeah. Okay. The next question, Pak Nasir. Besides controlling the nanofiber size, does the cupric oxide also play as antibacterial agent for microorganism screening or mass application?
Can you repeat it?
Besides controlling the nanofiber size, does the CuO, the cupric oxide, also play as antibacterial agent for microorganism screening on mass application?
Yes, I think it's good idea. If we can combine the nanoparticle or metal oxide nanoparticle by using another antibacterial agent, we can combine like that. For example, we can add the chitosan with nanoparticle and other active compound.
Okay. Also, another question: will copper always have effect on reducing the size of nanofiber? What about other transition metal like manganese, for example?
Yes, I think different metal has different characteristic, so we can check it. So we cannot is this, for example, copper oxide act like a lubricant. Also, we should check in the case of the mangan oxide or another metal. But the effect related to the viscosity of the solution. Okay.
So yes, actually, there's two questions that asking the similar thing. So I'll probably just combine these two questions. It's from Fabiola Rohani Marpaung from Universitas Negeri Medan, and then from Indasari Sihombing from Unimed as well. The question is about the styrofoam. Is styrofoam can be degrade in the environment? So can you also mention the side effect of styrofoam use in the daily life?
Yes.
And then also, can you suggest any alternative as the replacement for styrofoam?
Yes, I think this all of people concerned about the polystyrene, or the styrofoam is a trademark of polystyrene. So this is the problem is when we design the product, we need a long life product. In this case, in the polystyrene, it's very difficult to degrade the material. So if you want to the disposable product only use for one time, so it's better we use the degradable polymer, for example, for this packaging. So we should replace of the styrofoam or polystyrene for packaging application. I think it's better we use the degradable polymer.
The next question, Pak, is from Nana Misrocha from UIN Wali Songo Semarang. the question is about the mask that you develop. Is it meant to be reusable or not? If it is reusable, then do you have any calculation of the maximum limit of using the nanomasker?
Okay. We use the synthetic polymer in this in our nanomask. So we can use nanomask for several times. This is reusable. So you can wash this nanomask. So you can use many times.
Yeah, so it's actually like a fabric one that can be washed.
Yes.
So I still have some question for you, but I also have additional question from for Professor Pakorn. So
Okay.
the question for Professor Pakorn: what kind of interaction that can occur between the metal organic framework and polymeric matrix? What is the predominant rule of metal organic framework? Is it to reinforce the mechanical properties of the composite or any other function?
Okay. Yes. What we do is we just mix the MOF into PLA, and then we observe the mechanical properties of the polymers, and we see improvement in mechanical properties. This is from a general rule of adding some particles into the polymer. They usually make the polymer have higher modulus or higher strength, for example. But what we also see is if we vary the structure of the MOF, we can control the gas permeation ability of the through the film of the polymer, because MOF have different structure, especially porous structure. And so we have conducted further work that I do not show in here about the gas selectivity and also permeability of different type of gas through the film, composite film that are made from, for example, PLA and MOF that we obtain from chemical recycling products, actually. Also, in a separate work, we do not directly mix the MOF into polymer matrix, but we decorate the MOF on the surface of the polymer. This can even more exciting because MOF have unique properties on surface area or surface active function. Different type of MOF have specific function. And what we do is we only physically deposit the MOF on the surface. We do not see any type of chemical bonding for now. It's only what we call pregnated on the surface of the polymer. However, this can improve surface area on the MOF itself, because the polymer film or polymer nanofiber can act as substrate for MOF. And we can use this fiber or the film that are decorated on the surface for various applications. For example, filters for water mediums or absorption of metal ion from water, or absorption of gas, toxic gas from the atmosphere. These are some potential applications. But the main objective is we do not want to chemically bond the MOF to the polymer. Physical attachment is enough. but we want to increase some performance or other properties of the materials. Yes.
Okay. Professor Pakorn, another question from Dr. Fitri from UPI. We have been prepared hydrogel based on PVA, GA, Glaciraria, or red algae in our lab. Unfortunately, we face the issue in terms of film transparency. Do you have any suggestion to improve this film transparency?
The transparency of the final products, what do you mean?
Of the film. So this is the hydrogel is actually a kind of film, a thin film, and then the transparency is not very good. So do you have any suggestion to improve the transparency of the film?
So it is a copolymer of GA, right?
GA, PVA, and red algae.
I am not sure. I think maybe the incompatibility between the component may play some role in the opacity of the film. So if it is quite hard to improve the compatibility, right? And however, if they are in the form of copolymer, that should be feasible or possible to make them become clear or transparent. Yeah, if simple mixing of them and then they are not compatible, it is quite hard to make them become homogeneous.
So probably more like changing the composition, something like that, or because it's not compatible, so we need to find some replace some component, something like that, Professor Pakorn?
Right. For a simple rule of polymer blend, right? If we mix two components together, they may not be miscible at all composition, but there can be some magic composition that they can be miscible. So if you try to vary the composition, maybe you can find the suitable ratio that can produce the better transparency, I think.
Okay, so I think it's the last question for you now. So in the field of product development, besides using biodegradable raw materials, what else should product developers consider for sustainability of the environment? So this is probably the question come from a product developers. She asked, besides using biodegradable new raw materials, is there any other effort that can be taken to improve the sustainability for the environment of the product?
Okay. Yeah, that is very good questions. Actually, I would say if we want to design product for sustainable development, we need to design from the beginning until the end of life of the products. We need to have plan for each step of them. So the idea is for circular economy, it means we should use less amount of resources, but repeatedly use the resources with more effective way, which means that if the product go to the end of life stage already, we should find some way to convert them back into raw materials and remake them into high quality product again without using new raw materials or without throwing them away as waste that are harmful to the environment. So if we can fit everything into this concept, it doesn't matter that our product need to be degradable at the end. However, right, we have the plan for them. Then after the end, we convert them to something like that, I think. And also, if we can use raw material that are renewable and come from biobase with less involvement of chemical process. This also should be the way that we should think about. If we can use bio-based chemical directly or with minimum amount of modification or minimum amount of chemical use in the process. This should be the way that we think we should think about.
Yeah, so there's two ways. The first one is the improving the process and make it a more green process, probably reducing the amounts of material and also probably the setting the temperature just to make it a greener process. And then the second one is other than degrading the material, we can find a way to make the material to be able to be reused without having the decrease or too much decrease in the quality.
Yes, that is exactly, yes.
Thank you. Yeah, we still have some question to Dr. Nasir. We have three last question for you. The question is, can we have can suggest a very simple way to get the material like polymer probably from the coconut fiber and the pineapple leaf? Is there any simple experiment that can we apply to get the new material, polymer probably, or fiber from coconut and then pineapple leaves?
Okay. Yes, we can extract the fiber from the coconut fiber or from banana fiber by simple process. You can use the homogenizer, high pressure and high speed homogenizer, and then also you can use the ultrasonic process. You can extract the fiber, and also you can use the acid, but it's relatively dangerous for us. This there is three methods to extract the fiber from the nature.
And it's quite simple, yeah, Pak, yeah? It doesn't have a very sophisticated instrument to do so.
No, you can use the ultrasonic process. It's very simple.
Yeah. Okay, the next question from Eko Satriawan from Institute Science and Technology Anukaya Sumeneb. Can you also describe the nanofiber mask? Yeah, it's actually similar. Yeah, is it for only one off use, or we can use over and over again? And if we can use it, if we can reuse it, how about its antibacterial or antivirus activity?
Yes, I think we can use the nanofiber mask for many time because we can lock interfiber by special technique, so we can use it for many time. In the case when we use the natural antivirus or antibacterial, so if we wash this several times, so maybe the active compound will release to the water. I think it's much better we use the metal oxide as antibacterial or antivirus for long-term application of mask. But if we use only for several times, you can use the natural product.
Yeah, actually, the second question is, can we also use, for example, curcumin, kunyit, yeah, curcumin to replace the CuO that also has similar antibacterial and antivirus ability?
I think if you have the active compound from natural product, you can put it in the nanofiber. You can combine to the nanofiber during the nanofiber synthesis. But the problem is how many times you can use this active compound, because as you know, if they release to the water during the washing of the mask, so it will be not active.
Yeah.
But for 1 or 3 times, it's okay.
Okay, still a question, Pa, for you. We have in Indonesia, we have the crisis with the plastic bags, and this is becoming a great threat to our environment. Is there any kind of current invention or theory that can degrade this polymer in a short time? And then can we also have some replacement of these plastic bags using something that is easier to degrade?
I think we should use the biodegradable plastic as Professor Pakon described in his research. I think Professor Pakon can explain more detail because I see he worked in the biodegradable polymer, for example, PLA and another biodegradable polymer. I think.
Professor Pakon, can you add some answer to this question, as suggested by Dr. Nasir?
Yes, sure. For plastic bag, we know this is made from low density polyethylene or LDPE, and it is polyolefin. And there are many research work, including our work, that develop the process to chemical recycling this polymer into a small molecule that can be used for other applications. And the process is called oxidative degradation that I already said. And I think in not very far future, it should be in couple of years, this process should be practical in commercial process. And therefore, we should not be so worried about this. I think there should be a process that we can convert them. This chemical recycling process is much better than the normal mechanical recycling that we practice at this moment, because when we use mechanical recycling, it means we just take the plastic bag directly, remelt them and make them into products. The properties will drop, and then the application of recycle, especially LDPE, is very low values. So that's not feasible, not attractive to do. That's why people just throw them away. However, if we can convert this, right, by chemical recycling, we break down the polymer chain, and then we convert this into starting materials, and then we can purify them, and then after that we can use that product to make new polymer with high purity or high value applications. So this is a promising way that we can look for in the near future. And for this moment, right, if we want to replace, if we want to reduce the effect of this plastic bag to the environment, we can reduce the use. For example, we can use some other type of bag, for example, or we can substitute this by plastic bags that are made from degradable polymers. However, one of the challenge of that is degradable polymer now is the price is still quite high compared to LDPE. That's why if there is no regulation from the government, right, to promote the use of degradable polymer as alternative solution to this plastic bag, it's quite hard to implement this solution. Right? In some country, if there is a policy from the government, this can be done, can be practiced.
Okay, so it's about
Yes,
the question is about polystyrene from styrofoam. Can you describe about the side effect of this, the inhalation of this styrene to human body? Is there any bad effect to human health regarding the styrofoam and the styrene as the degradation products of styrofoam?
Okay, yes, very good question. So if we concern about styrene or small molecules that are remaining in styrofoam products, I don't think that can be, we don't need to worry much about that, right? In industrial process, when they make polymer products, right, the remaining small molecule is very, very small, right, trace amount. That should not cause the problem that we worry about. However, if we try to burn this or try to apply pyrolysis reaction to cope with the styrofoam product, that can be worrying problem, because if the process is not effective, that can release some toxic chemical to the environment, right? And so that is what we need to worry about. And in our lab, we also develop another process to chemical recycling polystyrene as well. If we look at the structure of polystyrene, it has benzene ring, and this is quite similar to terephthalic acid. So what we are developing now is we try to do oxidative degradation of this polystyrene and make them into terephthalic acid, which is monomer of PET, polyethylene terephthalate. So yeah, so if we can successfully develop this process, the toxic chemical, right, that can be released to the environment can be minimized by this process.
Okay, thank you. I think that's the last question, but I actually have one request to Dr. Nasir, because last time Professor Pakon already described in the presentation about his group, his research group, and since one of the audience is interested in joining the Dr. Nasir research group, so he wants to know how to do the research on natural fiber composite, and then how to apply for to be part of your research group.
Okay. Okay. You can contact us by email. This is from where, Dr. Galuh?
Yeah. Sorry.
Yeah.
Can you repeat again? Sorry.
So he can contact me if he or she want to do research in nanofiber, natural fiber, or synthetic fiber.
Could you kindly send the email address or any contact number or email in the chat, just to make everybody know about the email address. if that's okay with you. Yeah. Okay, so I think that's the wrap up for the question and answer session. It's been a lot of question, and I think the two speakers has been very informative and given us a very new insight on the polymer composite and fiber composite. And for the next session, we have quiz. So please, could you, everyone who wants to join the quiz, everyone can join the quiz. So please check your chat. And then, okay, so we have the share screen here. This is the pin, the game pin. So please, you go to www.kahoot.it. And then you can also use the Kahoot application, and then type the game pin as shown in the screen, and then you join you will join the quiz afterwards. Bu Fitri, do you have any remarks before, or we just wait until the quiz over?
Just we run the quiz firstly, Bugalo, and then yeah, we can come to the final conclusion, final remark from both speaker and also from me as the, how to say, organizer of this activity. Okay.
Okay. Okay. Thank you, Bu Fitri. Okay, so yeah, please join the quiz by typing the game pin in the Kahoot application. So for the attendance link, we will provide it after the quiz. Yeah, so please everybody come join the quiz first because we have two attractive voucher for the lucky one, for the lucky winner.
And Bogalu, you can direct for starting this game. So just you counting down, then yeah, we will click start from here.
Okay, so okay, we already have like almost 50 participants. So can we do the counting down now, Bu Fitri, or Bu Fitri can do it, the counting down?
Okay, okay. So how many participants already? 46? Maybe we wait until 50, hopefully.
Yeah, 50.
Almost 1/3, yeah, from the total participants that join in this seminar.
So I think we have like around 200 participants, Bu Fitri, in this seminar.
Yes,
and
I guess. Yeah, almost constant.
Participants coming from Sumatra and then the Sulawesi.
Yeah. Not only student, I guess, but also the lecturer from various institution here. Yeah, very great connection, I guess, to Galo in this seminar. And yeah, we really had a great time here for discussion with the speaker.
The discussion, I think, is very fruitful. Many good questions from the participants.
Okay. I guess we can start, Bu Galo. Please counting down from 3.
Bareng-bareng, Bu Fitri.
Okay. Let me start.
3,
2,
1,
and start.
Start.
Popcorn, you can join with us, and also some of your colleagues who join with us for this seminar today. Even though we're still thinking how to send the voucher if you won the game. So actually, the voucher is a kind of internet quota, Bugalu. Hopefully, it's useful for the winner, yeah, to be used for many purposes.
Bu Fitri, I thought it's going to be fun question, but it's a very serious question.
Yeah, we still difficult to consider the funny, how to say, more not funny, but very easy questions regarding the content. But I guess, yeah, since the audience keep seriously, I think during the presentation from speaker, so I do believe the audience can join. Okay, next, Bu Mita. This Ibu Pero Ginting, still leading here.
Leader. Oh, okay.
Actually, the question is very basic, Bu Galuh, regarding to the polymer characterization and so on. Even though the speaker not mention how to say directly, yeah, in the presentation. Yeah, but we can get the how to share the information from the presentation. So now we come to the fourth of the last.
Yeah. Two last question.
Yes. So this kind of quiz also very good for us as the organizer, Bugalu. We can get the feedback from the participant, not only from the question or something, but how much the participant can how to say absorb the information that we deliver during the seminar. And the other thing, this the best way that we have to appreciate very great attention from all.
Wow, number 3 is Ibu Mia. Number 2, Ibu Mia. And then the winner is Ans, whoever it is. So Ans, no, of ENS.
Wow, all correct. 5 questions.
Yes, yes, Prof. Do you have any other portrait to appreciate the participant?
So this is very, very attractive activity. Yes.
Yeah, this the way, Prof, how we conduct the seminar. Yeah, hopefully we can follow the lecture from both of you, but as well, yeah, we have a very how to say many great time here. So also the funny things, yeah, during the
Yeah. Okay, so I think we ready with the attendance link for anyone who haven't fill in the attendance link, because please fill in it and then fill the forms, and then the e-certificate will be produced based on the data that you put in the attendance link. Okay, so I think for the last session, I will give some time to Dr. Fitri Hoirunisa as the chair of this program. Dr. Fitri, please, the time is yours.
Okay, thank you, Bu Galuh, for very great delivery and also great, I guess, sharing these sessions. Yeah, we really have very fruitful time for hearing many great and valuable information from both speaker, as well as the good interactions during the discussion session. And on behalf of the Dean of Faculty of Mathematics and Science Education, as well as the head of our chemistry department, and also the organizer of this world-class professor program. So we would like to thanks and deliver our best appreciation for both speaker. One is for Prof. Pakor, and the second one is for Dr. Nasir. So here is the certificate that we provide for both of you. Thank you so much for your very great contribution on our first seminar. We do hope this can stimulate, how to say, the other Indonesian scientists, to improve research work, as well as maybe try to, how to say, to initiate the connections, not only with Prof. Pakor, but also with Dr. Nasir. So this is actually the main target of our seminar. So hopefully later on, Dr. Nasir as well as Prof. Pakor not only connected to me gitu ya, individually, but also later on we can have more interactions, more activity with both speakers, And I do believe many, how to say, current progress, current information that really update that could be, I guess, how to say, inspire us, yeah, to improve our research work. And for this is the template for certificate for all participants. So please fill carefully the recency link that we provide in the chat room. So don't make any mistake for your name and also your affiliation. Sometimes we have to resend the e-certificate. So we wait your response until 4 p.m. And then later on, quickly, we will send the e-certificate for all of you. So finally, before we close the session, I would also like to thank to Bugalu for very great contribution and also great role during this, how to say, seminar. Also, we provide the e-certificate, and thank you so much, Bugalu. The seminar really, how to say, goes very well. And then, yeah, we really had a great time here. And just you, how to say, miss the information for registration link. Here we enclose for you. So please click the link or retype this link below, and then you can come to the registration form. And here is the final information from our side. So we are still very welcoming all of your participation for our second seminar. The seminar itself will be held on 30th of October, and the topic that will be delivered during the seminar is about the strategy, how to say, mostly the strategy, maybe how to publish our research work on the reputable international journal based on the, how to say, great experiences that Popcorn had, as well as the another invited speaker. Here I, how to say, briefly introduce him. He is the actually one of Gajah Mada University lecturer, and also he in charge for the, how to say, university publications, how to say, affair in Gajah Mada. So hopefully Propakon as well as Dr. Sunu on the second seminar can share with you of the best practice, and also the great strategy and how we can write effectively, during, for example, the do that we have, and how to target the journal that, how to say, appropriate with our research work. And before we are closing this seminar completely, so I would like to give a time to Propakon and also to Dr. Nasir to deliver your closing remark for our seminar, and also maybe to say goodbye to all participants today. Please, Propakon, maybe firstly.
Okay. All right. Thank you very much. And I am very pleased to be part of this program, and also especially today that I can share the progress of our work to everyone. And if you have questions or you want to maybe start some collaboration work with us, you can also contact me. And I think my email is also listed somewhere.
Yes.
And I can be contacted by email, and then we can discuss further if you like. Also, another thing I want to announce is at SIIT, we have many type of scholarship for graduate student, master or PhD level, even postdoctoral position with very competitive benefit will be announced very soon from our university within the end of the year. So you can also contact me if you are interested in that. For faculty members, and we also have a program that is called a visiting professor to stay like in a short-term period with us as well. And also, please, if you are interested, please let me know. All right. And also, thank you very much, Dr. Kalu, for a very wonderful moderation of this session. Thank Professor Friti and also UPI, right, for making this session possible. And thank you everyone for your kind attention. Thank you very much.
Thank you so much, Prof. And then secondly, we invite Dr. Nasir.
Okay, I'm very happy to join this conference, and I'm very glad to share our research to our all audience. And it's very interesting question and answer. And I think in the future, all of us in the conference attendant, we can make a discussion, or if we interest to join the research, I think it's better. We can collaborate in the research, so we can more advance in our research in the future. Okay, thank you very much, Ibu Dr. Fitri, for your invitation to us to present in this conference. Thank you.
Thank you very much, Pak Nasir. And then since this moment is very precious, I do believe for us, so I would like to ask you to turn on your video. So maybe Bu Galuh, for the last session, I would like to take the picture for all participants. And since this activity will be reported to Ministry of Education, so please kindly show your video. Then just for your information, we recorded this seminar to the one who wanted to replay the seminar activities. It will be displayed on our department website. So soon it will be ready on our department website. So I will counting maybe to make everyone ready with very cheerful cheerful face, even though it's already moved to late afternoon. So first I will try with the first layer of this tendency. Still I see some attendance with the closed video. If you don't mind, so could you please turn on the video, please, for a moment? Okay. I will count 1, 2, 3. Most of you just not keep smiling. So could you please share your great smile to us? Okay, 1, 2, 3. Very nice. Again, 1, 2, 3. Okay, another pose, more relaxed, more more fun. Okay, 1, 2, 3. Selamat sore Pak Haipan. Okay, another layer. 1, 2, 3. Okay, just please keep your smile. 1, 2, 3. Okay, and then again, 1, 2, 3. And then the last, your freestyle, please. 1, 2, 3. Okay, thank you so much. Thank you so much for your great cooperation. Finally, we can capture the great images. Actually, just for your information, Prof. Parkon very skillful on taking the pictures. I've been following his Facebook, so every day he entertained us with very great photographs with the great angle, I guess. Okay, so finally we come to the end of this seminar. So we do hope that all of you can join us again on the 15th of October. Okay, thank you so much for your great attention. Again, I should deliver my sincere thanks to Prof. Parkon, to Dr. Nasir, as well as to Bu Galuh. Thank you so much for your great contribution. And see you again on our next seminar. Stay healthy, keep distancing, and don't forget to be happy. Have a nice weekend. See you again. Bye-bye.
Bye.
Bye.
Thank you so much. Thank you so much.
Thank you.
Bye.
Thank you, Prof. Thank you, Pak Nasir. Thank you so much.
Thank you, Bu Fitri.
Thank
Thank
you.
you.
Thank you.
Bye.
Bye. Ima.
Terima kasih semuanya, terima kasih. Insya Allah sertifikat
Bye.
4 ya, 3D ke email masing-masing.
Ya Bu, terima kasih.
Ya. Mohon pastikan tidak mengisi nama dengan nomor telepon. Bu Galuh, hatur nuhun pisan Bu Galuh. Very wonderful Bu Galuh. Iya, iya. Iya. Ya, Bu Galuh, beautiful and with the beautiful flowers. New project of Bu Galuh.
Hatur nuhun.
Ya, thank you so much Pak Nasir, hatur nuhun.
Ya, terima kasih banyak
Ya,
Bu
mohon
Fitri.
maaf atas segala kekurangannya Pak. Mohon maaf. Ya.
Ya, sama-sama.
Materi seminar dari semua speaker akan kita siapkan di Google Drive dan itu akan kita deliver sekaligus dengan sertifikat ya, akan kita kirimkan. Layar ini akan tetap kita on kan? Oh ya, layar ini akan tetap kita tayangkan sampai jam 4 karena masih ada sekitar 51 partisipan yang belum melakukan registrasi ulang untuk keperluan e-certificate. Bu Mita, ada link YouTube-nya nggak? Just in case ada temannya yang tidak bisa hadir di sini dan kemudian mau bagi partisipan atau siapapun yang tidak sempat mengikuti seminar ini, we are very happy to share the record of this seminar on our YouTube channel. So please please refer to http://bit.ly/deplicum.up ya. Yeah, that's the link for our YouTube channel. And don't forget to like and subscribe to make our websites being famous, getting famous. Okay, thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.